This episode is sponsored by Honeybadger. In addition to Honeybadger's great error monitoring service, they also have an uptime monitoring for web developers. And Honeybadger has recently shipped an update that allows for public status pages that can help communicate outages to your customers. In addition to your uptime monitoring, Honeybadger now monitors your SSL certificates. And Honeybadger now has actions which will allow you to do bulk updates to all your errors, or you can set defaults for incoming errors. In this episode, we're going to have a look at HTTP streaming and also using a large language model that is self-hosted on this Apple computer. So I'll type in a message, and then you'll see that it streams the response. We can then give it another prompt, and when we send it, it'll start streaming out the response, and once the response is finished, then a stimulus controller will then format the document. And so this is really cool because up to this point, I haven't really messed around with large language models and getting a streamed response, meaning that as the inference from the large language model is taking place, we are getting real-time feedback on what it's responding with. And the problem with this up to this point is that it's not taking in the context. And in the next episode, we're going to have a look at context. So as we converse, you'll see that it is taking the previous conversation into account. So we're not going to be covering the context in this episode. We're just going to be getting the large language model up and running. And then we're going to set up our Rails application with the background job to interact with the large language model. And then we'll stream and broadcast the response. And so one thing that I believe a lot of people have a misconception of is how the large language model actually works. So we're given each one of these inputs or prompts, and then it's not thinking about what kind of response it wants to give. Instead, it's looking at just a few characters each time, and it's doing the calculations that it thinks that the correct response should be this next character, period. And then the response after that, it should generate a P, and then a E, T-E-R, space, and so forth. So it's not thinking about collectively the entire response, but it's taking in that context and trying to guess what's the probability of the next letter it should enter. And so that's how you get into situations sometimes where the large language model isn't really giving you the desired results. If you do have a very narrow classification of different kind of responses you want to give, then a large language model most likely isn't what you're looking for. You're looking for more of a classification model. And somewhere where you may have seen something like that is when you call on the phone and you're speaking with your voice, trying to explain a general problem to the robot on the other end. It's then going to try to understand what you're saying and then classify it into one direction of help. And you also want to be careful if you are implementing something like this on your website and you expect it to give accurate results to the end user. I think that over time, in the next few years, we're going to get a lot better models that we can self-host locally. However, currently as it is today, we are still kind of limited. The model that I'm using in this episode is the Mistral, which is a 7 billion parameter model. So it is fairly good. However, I have seen situations where it's just given back incorrect information. So to get started, we do need to install a large language model on our computer. And to do this, I'm going to do a brew install Ollama. And what I really like about Ollama is that it's very simple. There's not many moving parts with it, and we can just set it to run, and then we really don't have to think about it. If we do a Ollama list, then it's going to show all of the different models that we have downloaded. I do have quite a few downloaded, and keep in mind that the larger model that you use, like a 7 billion parameter, its inference is going to be a lot slower. However, the Mistrals are about a 7 billion parameter, and these are pretty quick. And another thing that I like about Ollama is that it has an OpenAPI compatibility API. So a lot of the functionality that you would use with OpenAI, you're going to be able to use with Ollama. And another really cool thing is you can create a model file. A model file will basically consist of a few different parameters, and then you can create a model off of that model file. And when you do that, you can then reference that model name within your application, and then it'll run the inference on there. So you could actually have multiple models running on the same computer. And if they're using all the same base model, then you're going to be able to have multiple models working at the same time because they all share that same base. One cool example of that is a Mario model file where it's using the Llama 2. It has a parameter temperature of 1, and then it has a system message. The message is you're Mario from Super Mario Bros. Acting as an assistant. And so the kind of inference that you get back from this would be in the style of Mario. So for this, we are going to be using the Mistral latest. So if I did a ollama pull in the Mistral latest, then it's going to download the latest model. So from here, we're pretty much ready to use it. So I'm going to generate a new example application, and it is going to be using Bootstrap and ESBuild, but overall, we're just going to keep it very basic. And so in my sample application, I just have a welcome index page. And within here, I want to render a form. So we're just going to render a form, and this is going to be within our welcome page. Within this form, we just want to take it to a URL. And in our URL, let's just make it the chats path. So that means that we will need a chats controller with a create action. And we'll give it some HTML. We'll give it an ID just so we can reference to this form later, because we are going to want to clear it out once we make a post. And then we'll just add some Bootstrap classing, in this case a margin top of 3. And this form is going to be pretty simple. We're just going to have a div with a class, and we'll have a row. We'll have another div with a class of a column, and we'll just make it a pretty wide column. And then we're going to do the same, but we'll just make it a column width of 1, and then we'll close this out. So within the first column, we're just going to have a text area. So within this block, we have our form. We'll do a form.text_area, and we'll call this text area our message. We'll give it a class, which is just going to be the form control, and a width of 100. We can set a placeholder for your message. And I'm also going to set the autofocus to true. So when we come to this page, our cursor is going to be placed in there automatically. Then we can have a submit button, and we'll call that send, and we'll give it a class. And the class is just going to be a button primary, and a width of 100 as well, just to take up that full column width. And so that's all we need to do on our view here. We can then go into our routes.rb file, and within the routes.rb, we're going to have a resources for our chats, and we only need the create action. So I'm going to generate that controller, and within this controller, we need to create our create action. I don't like putting a lot of logic in here, so instead, we're just going to have a chat job that will then perform our action. So we'll have a perform_later for a chat job, and then we're just going to give it a params and a message. So the message that we put into the text area, we're just going to send into this background job. And typically, we wouldn't need to render anything, but because we are using Turbo, we do want to clear out that text box whenever this form is posted. So we can do a render turbo_stream, and then we can do a turbo_stream.replace. And remember, the name of that form is chat_form, and we can replace it with the partial, and that's going to be under the welcome and the /form partial. So just to make sure that this works for now, I'm going to comment out the chat job, and we can start up our Rails application. If we come to our application and refresh, we have our message. As soon as I hit send, we should see our message go blank, and our cursor comes back into the chat box, so that works. So now we need to create this chat job. And this chat job, again, is just going to be taking in that one parameter. So we'll create that job with the Rails generate job, and we'll just enter in chat to generate that job. And so this chat job is going to contain all of our business logic for interacting with Ollama. And so the parameter that we're taking in is our prompt. And then we need to get some kind of URI. And this URI, I'm just going to set equal to our application's host that has the Ollama. So that's going to be our HTTP. And then we're going to set it to our local host because it's running on this computer. And by default, Ollama runs on port 11434. We're going to use the API generate. So we can make a request is equal to the net, and then HTTP post. We'll create a new instance with our URI, and then we can set our content type. The content type is going to be the application/JSON. And then we can set our request body. So the request body is what we're going to be sending over to the Ollama. We do need to include a model. We also can include our prompt if we wanted to give it a temperature. And the important part here is that we have a stream. So the stream we're going to set to true. So that means that once we send the prompt, then as it's starting the inference on the large language model, it's going to be sending us back a bunch of different chunks, which are going to be in the form of a JSON. So for our model, we want to use the Mistral::latest. And for our prompt, we can't just take in the prompt from the end user because it does need to be formatted. So I'm going to create a private method, and we're just going to call this our context. And the context does need to take in our prompt. And for the API generate, and for the Mistral, that prompt, it does need to have a certain format. So it's going to be an instruct, and then we can interpolate in our prompt, and then we can close that instruct. And that's really all we have to do for that. So we can invoke this private method, context, passing in our prompt. And for this request body, we do want to make sure that we call the toJSON on there, but then we can go ahead and make our request. So we'll have the net HTTP, and then we'll start to the URI host name and the URI.port. We'll create a block, and within this block, we basically need to do a few different things. The first thing is that I want to broadcast an initial message back to the user on that page, and that broadcast is going to be the initial frame. And then we need to make the request to Ollama, and kind of a part 2 of that request, we're then going to receive the chunks, and then we need to broadcast the chunks back to the browser. And so if we have multiple frames coming in, we want to make sure that we are identifying these with a random number. So we'll create a local variable rand, and we'll set this equal to the secure random hex, and we just need to be a small number. We can then broadcast our message, and we want to target some kind of div. So I'm just going to create a messages, and then we need some initial frame. So I'm going to again put this in a private message. We'll just call it message div, and we need to pass in that random number. So let's go ahead and set this up in our view. In the index, all we have to do for this is create a div with an ID is equal to messages, and then we close out that div. That's it. This message div is going to be a little bit more complicated. And so it's just going to be a div with an ID. We need to set equal to. We'll interpolate in our random hex. And then I'm going to give it a class, and it'll just be some simple bootstrap classing. And so that's all we really need to do for the message div. But the more complicated thing is going to be this broadcast message. So this broadcast message is going to take in a target and then also a message, because we have our target as the string messages, which again is the ID that we set up in our index.html. And then the message div is going to be the message that we want to broadcast. So because this application is using Turbo, the easiest way to do this is if we do a Turbo and then a streams channel, we can do a broadcast, append to, and then we need to give it some kind of channel. So I'm just going to call this welcome for now. And then we need to have a target, our target. We'll just make our target. And we want to then broadcast an HTML, which is our message. And so that's actually all we have to do for this broadcast message. So in this welcome that we are targeting, we need to have up in our HTML, a turbo, stream from, and then this welcome. So we are going to be using action cable to receive all of the responses. So back in the chat job, after we have broadcasted the initial message, we can now make our request with a http.request, and then we want to send the request, and we'll get a response. With this response, we can do a response.read_body, and this will provide us a chunk. So with this chunk, we can then process it and then have that broadcast back to our Rails application. And so before we continue, what I want to do is just log out each one of these chunks. So I'm going to do a rails.logger.info, and then using an emoji so we can see this easier in the console, I'll just interpolate in the chunk. And at the top of the file, I'm just going to require the net HTTP just so we don't get an error when trying to use that library. But we're pretty much good to test this out for now. So we'll do a bin dev to start up our Rails application. And then within our browser, we can just go ahead and give a test message. So the thing that we would expect to see is a blue bar that appears, which is our div. And we got that. And then we see that we got a whole bunch of requests coming back. And so this chunk is in a JSON format. And we have the model, Mr. Latest, the date timestamp, and then the response. And then we also have a done is true or false. So the true one, we got an empty response, but the done is true. So now that we know what Olama has given us back, we now know how we can work with this. And so I'm going to create another private method called process_chunk. And this is just going to take in our chunk and then also that random value so we can then broadcast that. So down at the bottom here, we'll have our process chunk. And so let's go ahead and parse the chunk. So we'll do a JSON.parse of that chunk, and then we can check if it's done or not. And so we'll just get the JSON done. If it is done, then we can do one thing. If it's not done, then we can do something else. And for the message, we could just set that to the JSON response. However, I found that if that response is 0 or has just an empty space, then it might be better to have a break instead. So we can do a JSON response, and then we can make sure it is a string. We can then strip, size, and check if it is 0. If it is 0, then we can just have a break. Otherwise, we can just return that JSON response. And so if the message is not done, then we can just broadcast our message, and we want to target the random. So before we use the broadcast message to broadcast this div. This div had an ID is equal to random. And so now we want to target this div that we had already broadcasted, and we want to broadcast the message. And so I'm going to save this and we'll test it out for now. We'll start up our Rails application. We'll refresh the page and we'll just send a test message and it works. And so that's really cool. But there are some problems. If we say write a simple Ruby script, you'll see that it comes back and it comes back in a markdown format. But it doesn't really do anything with this, and this isn't very legible. So instead, what I would like to do is that now that we know we have a way to figure out when this is done, we could actually create a stimulus controller that has a markdown processor, and then we can process this message. So the way that we can do that is this div that we are creating. We can add a data controller, and let's just call our stimulus controller the markdown-text. But the tricky part here is we can add the stimulus controller here. However, we need some way when this message is done to then trigger a function on this stimulus controller. And luckily, stimulus has a function to do that. But before we do that, I'm just going to reformat this HTML just so it's a bit easier to read. And I'm going to do it with the here doc. And I just like using the here docs because it supports the multi-line HTML and it'll just be a bit easier to read. So for this markdown text stimulus controller, I'm going to have a updated value and we'll just set it equal to nothing. And so the idea is that we want to broadcast a message, but we don't want to broadcast the empty message. Instead, we want to send our own message. And this message is going to be a script where we can get our document and we'll get the element by ID, and we want to get that random ID. With this, we can get our data set and the markdown text updated value, and we can really set it to anything because what we're going to do on the back end of our stimulus controller is have a hook when this markdown text is updated, and then we can close out this script. And so this is going to get broadcasted and then it'll get executed. So now we have a way that once the message is done, we can then perform some kind of JavaScript action on it. So we need to generate the stimulus controller, and we called it the markdown-text. And within this stimulus controller, we are going to bring in a few different libraries. We're going to bring in marked and then also highlight.js. So we can do that with a yarn add marked, and then with a yarn add highlight.js. So we can import these in. We'll import, and for the marked library, we're going to have marked, and we'll import this in from marked, and the highlight.js will import in the highlight.js from, and then the highlight.js library. And so we don't need a connect function. However, we do need to assign the static values, and we'll set this equal to our updated, and that's just going to be a string. So whenever the updated value changed, and this is a built-in function that we get with stimulus because we have a value called updated, we have the updated, and then the value changed is basically a listener. Whenever this value changes, it's then going to execute this function. We can get our markdown text, so we'll just set a constant markdown text is equal to this.element.enter text. Or we can just get an empty string if it didn't get anything. We then get our HTML is equal to the marked.parse of this markdown text. We can set this.element enter HTML is equal to the HTML, and then we can loop through this.element, and we can do a query selector where we want to get all of the pre-tags. We can then loop through each one of these, and when we loop through each one of these, we can then just call the highlight.js highlight block of our block. And actually believe that the highlight block is deprecated, and instead we need to do a highlight element, but then that should be pretty much good. We do need to come up in our assets, in the style sheets, and in our application bootstrap, we need to use the highlight.js/styles, and the style that I'm going to choose is just the github-dark.css. In this way, we'll get the styling. And for our pre-tags, I'm just going to add a padding of 10 pixels. And in the chat job, I was missing a period on the dataset markdown text update value, so once we add that in there, we should be pretty much good to test this out. So coming back into our Rails application, we'll refresh, and then we can give a message and we'll send it. We see that it's still generating, and then once it's done, it formatted the text. And so there's so many use cases that we can do with this. I would try to keep it more simple because again, this is just a text generation. So it's trying to predict the next word or a few characters that it thinks that would match a proper flow. So that's why the accuracy of these can be very spotty sometimes. And so again, in the next episode, we're going to extend this where it's going to take the context into account. So when we send a message, it's still going to function the same, but then we can ask questions about it. Like, what was the name of the function you created? And then it'll respond that it created the function greet. And so that's going to be pretty cool because then now we're taking different kind of context into account. You can set this to where each user is having their own conversation, or you can have individual chat rooms where it's then broadcasting to just that specific room. And finally, and again, if you do implement something like this in your application, then you want to make sure that its use case isn't going to get you in trouble. Because even recently, there was a case where Air Canada had a chatbot and it gave the customer wrong information. The customer ended up suing the airlines, and the court awarded the customer $650. So there can be real consequences in just releasing a chatbot in the wild. That's why for a support help, I like a classification model more so than a large language model because the scope in which it can answer things is a lot more narrow. So you lose a bit of that AI feel to it, but you also get a lot more accurate and or sometimes limited responses because you're basically telling the statistical model that based on this user's input, we believe it fits into this classification or category, and this should be the response. If the user then responds to a affirmative action or decline, then you can either proceed to execute this function or exit the chat. Well, that's all for this episode. Thanks for watching.